Welcome to the Intro to React tutorial series. In this tutorial, we're going to be going over the basics of React by building a tic-tac-toe game in our interactive playground. So, the techniques that you learn in this tutorial are going to be fundamental to building any React app, and it'll help you get a deep understanding of React. This tutorial is designed for people who prefer to learn by doing. If you prefer learning concepts from the ground up, go ahead and check out the ReactJS documentation. It's really good. But here, we're going to be going over actually learning by doing, because at Clientside.dev, that is what we believe is the best way to solidify these programming concepts. Okay, so go ahead and pull up the editor with me. And you can find it at clientside.dev/problem/reactbasics. So you'll see that we have some starter code. And so this starter code is using what's called React class components. Okay, so these are class components. And if you want to see what we're actually going to fully build, you can look at that solution preview, and you'll see that as we go through, we get this history of the moves that we made, and we can actually go and click through them, and it'll remember where we were in our game. Okay, so that's real fun. Okay, so we're going to divide this tutorial into 4 sections. So number 1 is the setup, right? So we have the starting point here. Number 2, we're going to go over the fundamentals of React. Specifically, we're going to go over components, props, and state. Don't worry if you don't know what those are yet, you will in a moment. And then we're actually going to go ahead and complete that game and build out the most common techniques in React development so you can see them firsthand. And finally, we're going to add that time travel, that history that you just saw. We're going to add this functionality in. And that's going to be kind of the closing of this React Basics course. So let's talk about a little bit of the prerequisites here. I hope that you have some background in HTML and JavaScript. If you don't, go through the crash course in the curriculum. Our crash course is pretty quick with those, but I would also recommend that you actually go through the JS Mastery course, just because React is built on top of JavaScript, and if you understand how JavaScript works, then you will have a much better time building these things out, right? At its core, we're just writing JavaScript, but React kind of abstracts away a lot of stuff for us. And specifically, with JavaScript, I recommend that you understand ES6, which is what that JS Mastery course is really going in depth on. Okay. Cool. So now that we have that, let's get an overview of how React actually works. So React is a declarative, efficient, and flexible JavaScript library that allows us to build user interfaces. So it lets you compose complex UIs from small and isolated pieces of code called components. So as an example, a component is board. Another component is game, and another component is square. And when we actually give this game, right, this tic-tac-toe game off to somebody else to use or another component to use, it's really simple because all they have to do is just call that component like this, and they get all of that functionality right out of the box. So components allow us to compose complex UIs by building them up of smaller pieces. So as you can see, the board is broken down into squares, and the game is broken down into a board, and maybe you want to have different types of boards. I don't know what type of tic-tac-toe games you're building. All right, so moving on from there, React also has this kind of funny XML-like this funny syntax that looks like JavaScript, or looks like HTML, looks like HTML, but is not HTML. This is what we call JSX. So it's a very powerful part of React. One of my favorite things about React, if I'm honest, And it's the fact that we can write essentially Java or HTML within our React code directly in our JavaScript file. So what this means is that rather than going and typing something like, document.getElement by class name, right? We've had to do that, and then you select the class name. So here maybe we want to get the board row. Rather than doing that, we can actually just adding some sort of value to this class. So, if we wanted to append these squares into it, then we'd have to write a for loop and then go in and do all that. JSX actually abstracts that logic away for us, and we can just write it in almost plain JavaScript plain HTML with JavaScript injected in there. So as you can see, we are actually writing JavaScript right here. Okay, cool. So, and let me just show you one last thing here. So evaluating JavaScript is really easy here. So we can say, let's say const state is equal to true, right? Then we can say state. So if it's true, just print true or print false. Like this. And you'll get true here. And if we switch this up, right, it's so easy. And so that allows you to really write complex logic directly inside of your components without having to write all that base layer JavaScript that can get a little messy. So I want to go further by illustrating what props are. So props are a very important part of React. So let me just paste in some code here. And I'm getting this from the ReactJS website, so full credit to them. But so we have this shopping list React component, and in it you see that we have it using this.props.name. Props are a way for us to send information between components, right? So in this case, we're sending the name of the shopping list and then displaying a list underneath that name. But you could also pass in this list as well as a part of the props, okay? Quick little illustration there, but let's actually get to the problem at hand. So let's talk about passing data through those props. So to get started, let's actually pass some props to our square component. And so we can do that by creating we have this render square method here. Render square is a function inside of this class component that takes a parameter of I, and then it returns a square. Okay, well, let's change this code to pass a prop called value and give it that value of I. Okay, so right now, nothing should be different. Next, let's go into our render method of square. And now that we've been given I, we can actually say we're going to render this.props.value. So now we can actually get those numbers, you see? Okay, very cool. This is just a simple illustration, but now you've just passed a prop from a parent, the board component, to a child, the square component. And this is how information flows in React apps from parents to children. All right, now let's make this component actually react to our clicks. So to do that, we can just use the built-in onClick method. And here we can just pass it a function. And so this function, we can just tell it to console.log, I was clicked. And so if we click that, there you go. And so to see our terminal, you just click this terminal here and bam. Okay, cool. As a next step, we actually want the component to remember that it was clicked, right? So we're filling in with 0 through 8 right now, but we actually want to fill it in with an X when we click it. So in order to do that, we can use the state, what's called the state of a component. And so let's actually build that out here. And so each class component has a constructor. The constructor, if you're not familiar with class components, hopefully you are through the JS Mastery course, but the constructor is executed the moment that a component is created. So whenever we create a square, this constructor method is going to be executed, and it takes the props of this component. And so you always want to call what is called the super with props here. And so in JavaScript classes, you want to call super when defining the constructor of a subclass. So all React component classes that have a constructor should start with a super call. Okay, this is just an important thing to remember. And you really won't be dealing with this too much, so just take my word for it here in this case. Okay, so on to the more important thing, which is the state. So we can say this.state and then give it a value of null. Okay, and so now we actually have the state variable with a value stored for each square. Now we'll actually change the render method to set an actual value for this square. So on our click, let's actually move this over to an arrow function here, right? And we can just say this.set state to value, and then let's call it X. And then here, let's change this to this.state.value, and there you go. You see that each one is tracking its own value. So by calling this.setState from an onClick handler in the square's render method, we tell React to re-render that square whenever its button is clicked. So this onClick calling setState is telling React to re-render. After the update, the square's this.state.value here will be X. So we'll see the X on the game board as we click on a square. And so when we call setState in a component, React automatically updates the child components inside of it too. So if there were any children inside of square, then those would be updated as well, which is very important to know. And that's something that you'll actually encounter later on as you start building more of your own projects. Okay, so hopefully now you see that we have the basic building blocks that we need for the logic for our tic-tac-toe game. And to have a complete game, we now need to alternate placing the X's and the O's on the board, and we need a way to actually determine if we have a winner and who the winner is. So currently, each square component maintains the game state, and to check for a winner, we'll maintain the value of each of the 9 squares in one location, right? So these are all kind of independent of each other at the moment. So we need to lift that state up. And by lifting that state up, we need to lift it up into the board out of the square. So we may think that the board should just ask each square for the square state, and although you can do this in React, it's discouraged because the code kind of becomes difficult to understand and it becomes more susceptible to bugs and it's harder to refactor. So instead, the best approach is to store the game state in the parent, the board, and then the board can tell each of the squares what to display by passing that prop that we learned about earlier. Okay, so this makes it a lot easier to maintain our components. So let's go into our board here and let's actually create another constructor with our props and call our super here as well. And then let's set a state for the board, and here we'll give it squares. Now, squares is going to be of type array, and we're going to make sure that there are 9 elements in there. And then we're going to fill them up with null. So when we fill the board in later, the squares array might look something like this. So it'll look something like this. Okay, underlying implementation of squares will look like that. Okay, and make sure that you don't have that. So in the beginning, we passed the value prop down from the board to show the numbers from 0 to 8 in every square, right? And in another step previously, we replaced the numbers with an X, like this. And so each square was determining its own state. And this is why the square currently ignores this value prop that we have. So even though we're passing in the number, it's being ignored. And so let's actually go ahead and make sure that this is getting the value from the squares. And to do that, we can just say this.state.squares and then get it at the index of I. Since squares is just an array, we can just get that. And so now each square is receiving the current value of the board at that index. And so if we come back up to render square here, right, we can just, or sorry, not here. Yep, here. We can say on click and then actually pass in that this dot handle click, and then we'll give it the index. So we haven't actually created handle click, and I like to split methods like this. So rather than just writing everything in line and handling stuff, it's much better to actually create your methods outside of the components so that you can actually see exactly what's going on, and also you can reuse this functionality elsewhere if you wanted to. So what I've just done here is I've actually passed in another property, another prop to square. So we need to handle that. So if we come back up to square, you see that we are only handling that value, and then we still have this on click that's doing some other stuff. So rather than doing that, we can say this.props.onClick. And it's that onClick that we received from board. So let's actually clean this up a little bit, make it look a little prettier. And so that is going to still be working as expected. And here we're not actually getting the onClicks happening yet. So now let's go in and fill out that handle click. So here we have to actually get the squares, which is going to be this.state.squares. And we're going to call slice on the squares. Now what slice is going to do is it's going to return a copy of the squares. We're not actually going to be manipulating the squares specifically right here. So this will make more sense in a second, as after I finish this code, it's a little hard to talk while I write this. So let me just get this here. So let's set the state to squares, and it'll just be this new squares. Okay, so what have we done here? Well, pretty straightforwardly, we're able to now, maximum depth reached. Okay, well that's not good. And it looks like we've got some error here. Yes. So this needs to actually be an arrow function. On click needs to take an arrow function here. And let's also, okay, this all looks good. So with these changes, we're able to, again, click on the squares to fill them the same as we had before, right? However, now the state is actually stored in that board, right? It's here, it's been lifted up into the board in this squares property. And so since the square is no longer going to maintain the state, the square components receive values from the board component, and then they inform the board component when they're clicked. So that informing happens when we call that onClick function inside of square, and that onClick function is actually defined here inside of the board. Okay, so that's actually how we communicate from the child out to the board, right? This board is calling the onClick from the board. This is the onClick. We say, hey, whenever you're clicked, call this, okay? And then that's inside of our board, and then this is in charge of actually setting the squares. Now, notice how in handleClick, we're actually calling slice and this is a way of creating a copy of the squares array to modify instead of modifying the existing array. And I'll explain why we create a copy of the square array. It's really got to do with immutability, right? Excuse me. In React, immutability is very important. So we're creating a copy of the squares array using the slice method instead of modifying the existing array, because there are generally two approaches to changing data. So the first approach is to just go ahead and mutate the data by directly changing the data's value. So an example of that is, let me paste one in here. An example would be if we did something like this, right? You create a variable and then you just set the value directly, right? That's how you would think to do it if you didn't know about immutability. Okay, but why would we want to do it this way, right? So in the same example here, let's copy another code example. So the same example, but the end result is the same, but by not mutating the underlying data directly, we gain several benefits. So number one is complex features become simple. So immutability makes complex features much easier to implement. So we'll actually go in later and implement that time travel feature that is going to allow us to review the tic-tac-toe game's history, right, as we go through, and then jump back to previous moves. But this functionality isn't specific to games, right? An ability to undo and redo certain actions is a common requirement in applications. And avoiding direct data mutation lets us keep previous versions of the game's history intact and reuse them later. Another reason is because of change detection. So detecting changes in mutable objects, right, ones that you mutate directly, is difficult because they are modified directly. So this detection requires that the mutable object be compared to previous copies of itself and the entire object tree to be traversed. So detecting changes in immutable objects is considerably easier. If the immutable object that is being referenced is different than the previous one, then the object has changed, right? That's as straightforward as it gets. And finally, a third reason for using immutable methods like this is, and this is the main benefit, is it helps you build pure components in React. So immutable data can easily determine if changes have been made, which helps to determine when a component requires re-rendering. And you can actually learn more about this if you go to this article. So let me just, in the React docs, you'll see how you can build pure functions, and they're really useful for keeping our code modularized and also making sure that our code doesn't update, doesn't re-render when it shouldn't, right? This is an optimization for performance. Like we talked about, children components re-render if the parents' props change, but pure functions allow us to get around that. Okay, so enough about immutability. We'll get more into it a little bit further down. Now let's talk about actually changing this square component into what's called a functional component. So a functional component is a modern way of writing React components. So I thought that it would be good for us to actually see the class components approach. But now let's actually write this as a functional component. So a functional component is a function, right, instead of a class. So here the same class would be written like this. And rather than writing a render method, we just return what we want to render. So in this case, we have this button. So I'll just do it like this. And it's the exact same functionality, but now it just looks a lot cleaner, and it doesn't work apparently. So we don't actually have this .props calls here, okay? So that's really straightforward. So when we modified this to a function component, we're also changing this onClick to be from props rather than from the state, the internal state here. So in order to actually make this work, we got to actually alternate between X's and O's, right? And so this is an obvious defect in the fact that we cannot mark O's on the board. So we'll set the first move to be X by default, which it is, and then we can actually modify the initial board state, right? So here we have the state. Let's say X is next, and we'll just set this to true. So we start off with X being next, and we can change this value here and alternate it as we click through. So each time a player moves, X is next will be flipped to determine which player goes next, and the game state will be saved. So we'll have to update the board's handle click function to flip the value of X is next. So in order to do that, we call this dot state dot, or this dot set state here. Let's also actually update X is next, and we'll say this is going to be this dot state dot X is next, and notice this exclamation at the beginning to flip that value, right? This is saying not, so the direct opposite of whatever the current value of the state's X is next value. So now this should actually just work, right? It doesn't work because we actually have to update this, excuse me. So squares at I is going to actually be equal to this dot state dot X is next. And so if it is next, then well, let's print an X. Otherwise, let's print an O. Okay? Now it should work. And there you have it. So that's working as expected. All right, so this is all fine and dandy, but we actually need to calculate a winner. So let's create a function here at the bottom, and let's call this calculate winner. And this is going to take our squares. So this is going to be an array of squares. Okay? And so in order to calculate a winner, we can be pretty naive about our approach. So let me actually copy and paste what I've pre-written here. These are the combos that result in a winner if they are all the same. Okay, so let's write a for loop to actually go through it. So I is 0. I is less than lines.length, right? Go through all of the lines and then iterate. So let's get each value. So we'll say A, B, and C is equal to lines at I. So this is a destructuring, an array destructuring. So A would be 0, B would be 1, and C would be 2 at lines at 0, right? And so we would actually get the values immediately there. So we store the values into ABC, and then we can check. So if squares at A and squares at A is equal to squares at b, and squares at a is equal to squares at c, then we can say return squares at a. Okay, and then otherwise we can just say, hey, we don't have a winner, we'll just return null. So here, given an array of 9 squares, this checks for a winner and returns x, o, or null, depending on this condition right here. So I hope this is pretty straightforward, but now let's actually go ahead and call this calculate winner. And so we're going to actually call this in the render method for the board. And so here we'll say winner, right? The winner is equal to calculate winner, and then we'll give it that state, and we'll call it the squares. Okay. Now, if there is a winner, then we'll say stop, statically putting this, and we'll actually make this status dynamic. So we'll say status is equal to winner, and then we'll give it the value of the winner, x or o. Else, if there is no winner, then status is going to be next. Oh, and let's actually define status up above, right? So let's say let status. So there we go. And then we're going to say next player. This is going to be this dot state dot x is next. If it is, then, well, we know it's going to be x, or it's going to be o. Cool. All right, so we can now change the board's handle click function to return early by ignoring a click if someone has already won the game or if that square is filled. So let's actually go up to that handle click here. And so we say const squares, we get all the squares. And then we can say if calculate winner squares, or there is already a square filled at that spot, then we just return. We don't actually get to evaluating this these next lines. So that's pretty straightforward. And there you go. So that is working. Now we have a fully functioning tic-tac-toe game. So let's see it. Oop. We are missing something here though. It should not be allowing us to keep going like that. Oh, and don't make this very, very dumb mistake here. You gotta make sure that you're actually returning outside of the for loop, because if we return inside here where I was, then it's just gonna always return null, so you're never gonna get a winner. So now this should work as expected. So we have the winner, we have a fully functioning tic-tac-toe game. Congratulations, guys. Okay, so that's all fine and dandy. We've got something awesome here. We can spend countless hours playing this game. Now, let's actually, as a final exercise, add time travel to this, right? Let's make it possible to go back in time to the previous moves in the game. So, if we mutated the squares array, implementing time travel would be difficult, right? We aren't mutating it. We're actually just updating it to a completely fully new squares array that we store up here and then set, right? We talked about this. However, since we use slice to create a new copy of the squares array and treat it as immutable, we're now able to store every past version of the squares array and navigate between the turns that have already happened. So we'll create another array and we'll call it history, and the history array will represent all the board states from the first to the last move, and it'll look something like this. So to give you a better idea, this is what history will look like, right? So this is before the first move, everything is null. Then we store the next value of squares, and then so on and so forth, and we're able to iterate through it and go back to previous states. So let's actually go ahead and implement that. So here, to implement something like that, we'll actually need to lift state up yet again. So we'll actually want game, right? We haven't really been touching the game component much, but we'll actually want the state to be lifted up into here. And this is going to allow the top level component to actually display a list of the past moves. And so it's going to need access to the history to be able to do that. So let's actually do that. So let's build up our constructor like we did before. Take the props, call super, and then create that state. So here, let's give it a history. And so in this case, history is going to be holding those squares, which is going to be an array of 9. And then we're just going to fill them to start with null. Okay, nothing new yet, other than that overarching or that parent history here. And then let's also add our, something's going on here. Let's also add that x is next. So x is next is going to be true to start. Okay, now the board component should receive the squares and the on-click props from the game component, right? And since we now have a single click handler in board for the squares, we'll need to pass the location of each square into the on-click handler to indicate which square was clicked. So in order to transform the board, we'll need to go through a set of steps, right? So first we'll need to delete the constructor in board. So let's go back up to board and let's get rid of this constructor. No longer need that. And then we also don't want to be referring to state here in any of these cases. So this is going to be taking this dot props dot squares and then also this dot props dot on click. Okay, and we'll also update the game. So now come back down here and we'll update this render method to actually take that history and then get the current spot in the history that we're at. So this will just be the history at history.length -1. So the very last point in our history. And finally, get that winner. And we're going to call calculate winner here with current.squares, right? Take all of that logic that we had up above and just transfer it here into the top level. So, okay, so now that we have that, let's go ahead and update our board to take the correct values. So board is going to be taking in our squares, which is going to be current.squares, and then our onClick method, which in this case is going to be taking in the index that we're at, and then passing it to the handle click that we just defined. And so we're going to have to actually get that handle click from above. So let's go ahead and grab that. So we're actually going to be returning. The status isn't going to be here anymore. We're not going to be doing this calculation here. It's going to be pretty bare bones. And then here we'll actually take this handle click and just completely remove it from there. And then come into our board, or sorry, our game, and then create it here. Okay. And in this case, rather than just copying and pasting, it's actually not going to work that easily. We're going to have to get the history from the state and then get the current from the history. All right. And then get the squares from current and call that slice, right? And now we can remove that. And so we keep that if statement here the same, keep this the same, and then create a new setter here. So we'll actually go and just update that squares part to actually read history. So history.concat, and this will take, concat, and this will take an array of objects, and this will be our squares. Okay, so what are we doing here? Right, we're actually just taking the current history object that we saved and then adding to the end of it the current state of squares. The concat is a little different than push, right? But it doesn't actually mutate the original array. So like we have been talking about, immutability is important, and so we use it, okay? And so now the board component only needs the render square and the render methods. So let's look at it here. You got the render square and the render method, okay? And everything else is now encapsulated within our game. So our components up above are now looking pretty simple. Okay, so now we can actually display the past moves. Since we're recording the tic-tac-toe game's history, we can display it to the player as a list of past moves. So remember, we learned earlier that React elements are just JavaScript objects, right? So we can pass them around in our application. So to render multiple items in React, we can use an array of React elements. So arrays have a map method, right? We know the map method, and it's commonly used for mapping data to other data, right? So for example, something like this is how you would map and double each value, okay? That's the map method. So we can actually use the map method on our history of moves and create React elements to represent them using buttons. So let's actually do that, right? So in our render here, let's actually go ahead and create a moves variable and go over the history. And so here we'll take, for each history, we have the step and the move. Okay, and so here the step is an array of squares, or is an object that has the squares, and then the move is the number. Okay, it's that index. So you can also say index here. Okay, so say here we'll say go to move number, and then use that index or that move variable, and then otherwise go to game start like this. So this is going to be the description of the button, not descending, excuse me. All right, now we can say return. This is where we create that React component. So this is moves is a list of React components, and basically a React component is just any use of JSX. So here it'll be a list item, and it'll be a button in there. Okay, and then let's go ahead and close off that list item. Here we are, and so this button, every time we click it, we actually want to call a method called jump to. So we'll create that as well. But we want to jump to that state, that point in time, using this index. So let's add that text from before, this description text, like this. And so now let's actually put that in here, right? So we have our ordered list that we need to still fill out, and this is just going to be our moves. And then let's also put that status here before we forget. And there we are. So as we're iterating through the history array, step variable is referring to the current history element, right? This is the current element. And the move is the index. So it's the current index that we can actually use to send to the jump to method. And so now let's actually go ahead and fill in jump to. So in order to fill in jump to, we have to actually set some other things up. Alrighty, so one thing to note here is if we open up the Google Chrome Developer Console, right? If you right click and click inspect, you'll get the developer console. You'll see that we have this warning here that says that each child in a list should have a unique key prop, right? So this is an important thing for us to be aware of. And so this is best illustrated with an example piece of code, okay? So let's say that we have these two list items, and then we transform it into the following, right? So looking at it, you see that we added Claudia in the middle and also updated some values. So in addition to updating, in addition to the updated counts, a human reading this would probably say that, we swapped Alexa and Ben's ordering and inserted Claudia between Alexa and Ben, right? But React, on the other hand, as a computer program, does not know what we intended. Because React cannot know our intentions, we need to specify a key property for each list item to differentiate them from their siblings, right? So when we render a list, React stores some information about each rendered list item, and when we update a list, React needs to determine what has changed, right? We could have added, removed, rearranged, or updated the list's items. So one option would be to use the strings Alexa, Ben, and Claudia in order to differentiate the values, right? So we'd say this is Ben, this is Claudia, and this is Alexa. You get the point, right? And this is our way of telling React, hey, look, this is how I want you to differentiate. Another option would be if we were getting this information from a database, we would use the database IDs as the keys, okay? And so when a list is re-rendered, React takes each list item's key and searches the previous list item for a matching key, just like that history variable that we created for keeping track of the tic-tac-toe moves. So if the current list has a key that didn't exist before, React creates a component. If the current list is missing a key that existed in the previous list, React destroys the previous component. And if two keys match, the corresponding component is moved. So keys tell React about the identity of each component, which allows React to maintain state between re-renders. If a component's key changes, the component will be destroyed and recreated with a new state. So key is a special and reserved property in React. There are a few other ones like ref, which is a more advanced feature. But essentially when an element is created, React extracts the key property and stores the key directly on the returned element. And even though the key may look like it belongs in props, right? It's just being passed down. It cannot be referenced using this.props.key. So React automatically uses key to decide which components to update, and a component cannot inquire about its own key. And so this is why it's really important that you assign proper keys when you're building dynamic lists. If you don't have an appropriate key, then you might actually even want to consider restructuring your data so that you do have one. And otherwise, you'll get this warning, and React will try to use the array index as a key by default. But this can be problematic if you're rearranging the order of the items or inserting or removing items. So if you're going to just display a list and never touch it, then this can be okay. But just keep that in mind. Okay, so let's move on to actually implementing the time travel component that we saw in the solution. So in the game history, each past move has a unique ID associated with it, right? It's the sequential number of the move. So that's going to be our key. And so the moves are never reordered, deleted, or inserted in the middle. So it's safe for us to use that move index as a key. So let's go to that game components render method again. Let's go down here, or list item, and then use that move variable as the key. And with that change, that warning should go away now. So we still have this jump to method that is not implemented. So if we actually went and clicked, we would get an error because it's undefined. But before we implement jump to, we'll add step number to the game component state to indicate which step we're currently viewing. So let's go to our state. Here we are, right? And let's add step number, and initially let's set it to 0. Next, let's actually go ahead and define jump to. And this is going to take a step as a property, or as a parameter. So here, jump to is just going to be updating the state to the step number. So in this case, it's going to be step, and then, let's make sure that we get this right. Step number, and set it to step, and then flip that X is next to be step modulo 2 equal to 0. Okay, so it's just saying if it's even, right, doing the modulo operator by 2 is just checking if it's even or odd. Notice that in jump 2, we haven't updated the history property of the state, and that's because state updates are merged, or in more simple words, React will only update the properties mentioned in set state, leaving the remaining state as is, right? So next, let's actually make a little change to the handle click method. So specifically, the history is actually going to be this.state.history.slice. And here we're going to go from index 0 to this.state.step number plus 1, right? Off by 1 because it's an index. Okay, so now it's actually accounting for which point of the state we are currently in once we actually do that slicing on it. Let's also make sure to set the step number here to the history.length so that it's appropriately keeping track of where we are. And finally, let's go in here and update the current variable here. And rather than being the very last item in history, it's going to be the step number. And now it should just work. If we go back, everything is working as expected. Go back, and we have a winner. So congratulations, you've created a tic-tac-toe game that lets you play tic-tac-toe, indicates when a player has won, and stores the game's history as the game progresses, and it allows the players to review a game's history and see previous versions of the game. To end it all off, let's go ahead and run our tests to make sure that we meet all of the criteria for this problem. Hopefully we do. And there we go. So that is the React basics introduced with tic-tac-toe.